Imagine this. A mysterious object from outside our solar system just showed up. And it's more than 100 times bigger than anything we've ever seen, including ʻOumuamua and 2I Borisov. Scientists are calling it a cosmic heavyweight, and its trajectory is about to cross paths with another interstellar traveler. Could this be a random cosmic coincidence? Or is something far stranger happening? Stay tuned, because what we're about to witness might rewrite everything we know about the universe. The discovery began quietly, through routine scans from deep space telescopes designed to monitor faint, fast-moving objects beyond Neptune's orbit. At first, it appeared as a distant speck of light, but as astronomers collected more data, the numbers became jaw-dropping. The object reflected far more sunlight than expected, suggesting either an enormous surface area or an unusual material composition. Gravitational calculations soon confirmed the unthinkable. This body is colossal, potentially rivaling the size of dwarf planets. Imagine something so huge that, if it were placed inside our solar system, it could reshape the gravitational balance of smaller moons and asteroids around it. Scientists describe it as a cosmic heavyweight, moving silently through the void at unimaginable speed. What makes this moment even more extraordinary is that humanity is witnessing it in real time. Just a decade ago, our telescopes were too limited to even detect such an object. Now, thanks to ultra-sensitive instruments and AI-assisted sky surveys, this interstellar behemoth has revealed itself, a visitor from beyond the stars. But here's where it gets truly fascinating. Its trajectory isn't random. The path of this giant is set to cross the orbital region of another mysterious traveler, 3IATLAS. And that's where things get very interesting. Not long after the first data came in, something unexpected happened. The observatories studying this enormous object began forwarding their readings to advanced AI systems, programs designed to analyze light patterns, composition, and motion at speeds no human could match. One of those systems, known as Quantum AI Deep Scan, immediately raised an alert. The reflected light wasn't behaving like rock, ice, or any known natural material. Instead, it showed precision-level uniformity, surfaces that seemed polished, structured, and mathematically consistent. In short, it looked engineered. At first, the team thought it was an error, maybe a sensor glitch or a calibration issue. But the results were confirmed again and again by independent telescopes. The pattern was real. Then came the shocker. When Quantum AI compared the data from this new object to previous readings of 3IATLAS, it found a 99.7% similarity in reflectivity and electromagnetic response. Two separate interstellar bodies, moving through space years apart, showing nearly identical artificial-like signatures. That defied coincidence. If you're as fascinated as we are, don't miss a single update on these cosmic travelers. Like, subscribe, and hit the notification bell to join us on this journey, because the galaxy is sending its stories, and you'll want to witness every chapter as it unfolds. Within hours, scientific channels lit up. Some researchers argued it could be a new class of interstellar metal-rich objects, relics from dead star systems. Others weren't so sure. A few whispered that the structure of the light echo looked modulated as if it carried a signal. Even NASA reportedly went silent on the data for several days, citing review protocols. Astrophysicist forums became battlegrounds, half the community calling it pseudoscience, the other half saying we might be staring at the first evidence of intelligent design beyond Earth. And as debate raged, the object continued its silent approach, aligning closer and closer to 3IATLAS, like two pieces of a cosmic puzzle moving into place. Now the question echoing through observatories worldwide is chilling. If these objects aren't natural, then who nor what sent them? As data from global observatories poured in, astronomers began mapping the object's orbit with extreme precision, and that's when the world took a collective breath. The new interstellar giant wasn't just passing through the outer solar system randomly. Its trajectory appeared to be on a direct collision course with the orbital path of 3IATLAS. It's an almost impossible coincidence. Our galaxy is vast, billions of stars, trillions of kilometers of empty space, and yet two separate interstellar travelers are now converging on nearly the same coordinates inside our solar system. Statistically, it should never happen, and yet it is. According to the latest orbital simulations, the two paths will intersect within weeks. near the region between Mars and Jupiter, a quiet part of the solar system that's suddenly about to become the most observed patch of sky in human history. Every major telescope, from the James Webb Space Telescope to Hubble, and even ground-based arrays in Chile and Hawaii, is now focused on a single point in space. But here's where things get even stranger. Both 3IATLAS and this colossal newcomer are showing synchronized velocity changes, subtle but measurable. It's as if they're adjusting course together. Some experts dismiss it as gravitational influence, but others argue the pattern looks too deliberate, too controlled. NASA, ESA, and several private observatories have reportedly scheduled continuous tracking sessions, while data from the Deep Space Network suggests a possible energy spike between the two objects. If true, it means we might witness the first ever interaction between interstellar visitors, or something far more mysterious. Imagine it, two alien objects, crossing paths light years from their origins, inside our solar system, at the same moment in human history. A meeting not of chance, but perhaps of design. And as their paths converge, scientists are asking one urgent question: what will happen when they finally meet? As these two colossal visitors drift closer to each other, astronomers are calling the new object a once-in-a-lifetime discovery, a cosmic archive frozen in time. Its enormous mass and mirror-like surface could hold secrets older than our own solar system, remnants from the birth of distant stars billions of years ago. High-resolution scans from the James Webb Space Telescope reveal complex surface patterns, ridges, grooves and heat variations that don't match any known natural formation. Some parts appear to absorb light, while others reflect it perfectly, almost like polished metal. Scientists believe these differences could encode the object's chemical history, each layer preserving the elements and radiation signatures from the interstellar medium it passed through. If that's true, this single object could tell us where it came from and what kinds of worlds might exist out there. Early spectroscopy data hints at exotic compounds never before detected. Traces of rare isotopes, silicate crystals aligned in unnatural symmetry, and organic molecules that resemble the building blocks of life. It's as if the object carries a molecular map of another star system across unimaginable distances. But that's not all. Its reflective shell emits faint electromagnetic pulses, rhythmic, repeating, and perfectly timed. Some scientists think it's just internal stress releasing energy. Others wonder if it's a data pattern, a kind of galactic record etched into its surface. A few are even calling it the Rosetta Stone of the stars. To study it, international teams are designing rapid probe missions, desperate to get close before it slingshots out of the solar system forever. The goal: collect fragments, scan its magnetic field, and decode whatever information it might be carrying. Because if this object really is a cosmic archive, a drifting library from another world, unlocking its secrets could rewrite everything we know about our origins, our galaxy, and perhaps who else has been out there watching. Despite the size and mystery surrounding this interstellar giant, scientists have been quick to calm public fears. Earth is safe. The object's trajectory, though massive and dramatic, will not bring it anywhere near our planet. In fact, even at its closest approach, it will still be farther away than Mars. But that doesn't mean it won't leave its mark on our solar system. Its sheer mass, estimated to be hundreds of times greater than 3IATLAS, means its gravitational pull is powerful enough to subtly disturb smaller celestial bodies nearby. Tiny asteroids, icy fragments in the outer belt, and even some comets might experience minor orbit shifts as it passes through. Astronomers have already detected small unexplained deviations in the paths of two near-Mars asteroids, possibly caused by this object's approach. To put it into perspective, think of a massive ship gliding through water. It never touches the smaller boats, but the waves it creates can rock them from a distance. The same effect may be happening right now, only on a cosmic scale. What fascinates scientists most is that the object's gravitational field seems unusually stable, almost fine-tuned. It's not tumbling chaotically like most asteroids or comets. It moves with precision, steady and deliberate, as if guided by design rather than randomness. NASA's Planetary Defense Coordination Office confirmed that there's zero risk of collision with Earth or any major planet. However, they're watching for potential side effects, micro-perturbations in the asteroid belt, changes in dust particle alignment, even fluctuations in radio signals bouncing through the region. Subtle signs that this visitor, though distant, is leaving a fingerprint across the solar system. Still, the reassurance is clear. There's no threat to humanity. No incoming impact, no extinction event. Yet the implications remain staggering. Because while it may not endanger us physically, its presence alone challenges everything we thought we knew about cosmic order and whether something out there might be guiding these visitors intentionally. As the colossal interstellar object drifts deeper into our solar system, humanity has united under one mission: to watch, record, and understand. Every major observatory on Earth is now locked onto a single moving target. From the frigid peaks of Chile's Atacama Desert to the high-tech domes of Hawaii's Mauna Kea, the world's telescopes are working together like never before. Space agencies have activated an unprecedented global observation network. NASA, the European Space Agency, JAXA, and even private organizations like SpaceX and Blue Origin are sharing live data streams in real time. It's a 24-hour operation, capturing every flicker of light, every gravitational twitch, every pulse of energy radiating from the object's vast surface. Using radar, optical, infrared, and ultraviolet wavelengths, scientists are peeling back the layers of this cosmic enigma. Radar mapping reveals faint geometric contours, massive angular ridges that shouldn't exist on a naturally formed body. Infrared scans show heat signatures that pulse in regular intervals, almost like an internal rhythm. And deep space radio antennas from the Deep Space Network have picked up faint, repeating frequencies, too structured to dismiss as random cosmic noise. To coordinate it all, the Interstellar Monitoring Coalition has been formed, a first-of-its-kind alliance linking observatories, satellites, and AI systems across the globe. The data volume is staggering. Petabytes of images, spectra, and signals analyzed each day by machine learning models trained to detect anomalies. And the results keep coming. Even amateur astronomers are part of the effort. Thousands have joined citizen science platforms, uploading telescope footage and helping refine the object's trajectory in real time. For the first time in history, humanity is watching an alien interstellar visitor. Together, every nation, every observatory, every satellite, all staring at the same point in space, wondering the same thing: what exactly are we looking at? Because if this coordination continues and the data stays consistent, we may soon have our first clear picture of what's truly out there, and whether this colossal traveler is just a piece of cosmic history or something sent with purpose. With every passing day, the mysterious interstellar object moves closer to the inner solar system, and time is running out. Once it swings past the sun, its incredible velocity will fling it back into deep space, possibly forever. That's why space agencies are now in a race against time, drafting bold plans for rapid response missions, robotic probes designed to chase the object before it disappears into the void. Behind closed doors, NASA, ESA, and even private aerospace companies are reportedly holding emergency meetings. The goal: to launch a probe within months, not years. Traditional missions take decades to plan, but this is different. Engineers are repurposing designs from cancelled asteroid interceptors and planetary defense projects, stripping them down to essentials: propulsion, sensors, and a reinforced communications array. If successful, the probe could perform a high-speed flyby, snapping high-resolution images, mapping surface composition, and measuring magnetic and radiation fields up close. Some mission concepts even propose deploying microdrones that could skim the surface, collecting dust particles or scanning for signs of artificial alloys. One proposal, called Project Prometheus, suggests using a next-generation nuclear propulsion system to close the gap faster than any spacecraft in history. A concept once deemed impossible, now suddenly urgent. SpaceX's Starship is reportedly being evaluated as a potential launch platform due to its raw payload power and rapid turnaround capability. But the challenges are immense. The object's trajectory is unpredictable, its speed staggering, tens of kilometers per second. Navigating a probe near it would require precision timing and near-perfect AI guidance. A single miscalculation, and the craft could miss its target by millions of kilometers. Still, scientists insist it's worth the risk, because this might be our only chance to study an interstellar object of this magnitude up close. Every piece of data gathered could reveal new insights into how these cosmic travelers form, what they're made of, and maybe who sent them. In the words of one NASA scientist, if we let this one go, we might be ignoring the greatest discovery in human history. And so, the countdown begins, humanity's most daring pursuit yet, chasing a visitor that may hold the answers to our deepest cosmic questions. If this massive interstellar traveler truly carries organic molecules or frozen reservoirs of ice, the implications go far beyond astronomy. They touch the origins of life itself. Scientists are calling this phase of research the biological window, a once-in-history chance to test one of the most profound theories in science, panspermia. The idea that life's building blocks are not unique to Earth, but may spread across the galaxy, hitchhiking on asteroids, comets, or interstellar visitors like this one. Spectroscopic scans from the James Webb Space Telescope and ALMA Observatory have already detected faint absorption lines, subtle chemical fingerprints, that could indicate complex carbon-based molecules, including amino acid precursors. These are the same ingredients that form proteins, the foundation of life as we know it. If confirmed, it would mean this object carries the same biological seeds found on Earth, Mars, and icy moons like Europa. But what truly excites researchers is how those molecules are arranged. Early data suggests they may exist in structured patterns, layered deposits protected beneath a reflective crust. It's almost as if they were preserved intentionally, shielded from radiation during their journey through interstellar space. Some scientists argue it's coincidence, nature's chemistry repeating itself. Others whisper something more unsettling. What if the object was designed to carry life? Back in the 1970s, Carl Sagan described the possibility of life's messengers, comets or probes, that might distribute organic material between worlds, seeding habitable environments. Until now, that was speculation. But with this colossal visitor, showing both structure and biological potential, those old theories are suddenly back in the spotlight. If the object contains even trace amounts of frozen microbes or prebiotic material, it could rewrite humanity's origin story. It might mean that Earth's spark of life didn't begin here at all, but was delivered by cosmic travelers just like this one. Billions of years ago, biologists, chemists, and astrophysicists are now collaborating on simulation labs to recreate the object's conditions, replicating its pressure, radiation levels, and chemical composition to see whether life could endure such a journey. Early tests suggest that certain extremophiles, microscopic organisms that survive radiation and vacuum, could make the trip intact. If that's true, then every interstellar object could be a potential ark, drifting between galaxies, carrying the DNA of countless civilizations waiting to be reborn. And that raises a haunting question. What if this object didn't just bring life once, but is returning to check on what it started? Whatever the truth, this discovery pushes us to see life not as a miracle confined to Earth, but as a cosmic pattern, spreading endlessly among the stars, one traveler at a time. As news of the object spread, something extraordinary began happening on Earth. It wasn't just scientists who were transfixed, it was everyone. Social media feeds flooded with animations and telescope images. Children in classrooms sketched the colossal visitor alongside the planets. Poets, artists, filmmakers, and even musicians began creating works inspired by it. In every language, the same question echoed, what does this mean for us? For centuries, humanity has looked up at the night sky and wondered if we're alone. This discovery, two massive interstellar objects converging in our solar system, has cracked open that question wider than ever. Suddenly, the solar system doesn't feel like a lonely island drifting through empty space. It feels like a junction on a vast, unseen highway of galactic travelers, a place where stories, matter, and perhaps life itself are exchanged. Philosophers are calling it a Copernican moment for the 21st century. Just as Copernicus shifted our view of Earth from the center of the universe to one planet among many, this event may shift our view of the solar system from a self-contained bubble to a node in a cosmic network. The implications ripple into religion, science, politics, and identity. If objects of this size, complexity, and possible artificiality can reach us, then what else might be passing by unseen? And for how long? Leaders are even holding special sessions at the United Nations and in major parliaments, not to discuss defense, but to discuss meaning. How should humanity respond if these objects are truly artifacts, or carriers of life, or even messages? What kind of civilization will we be when faced with evidence that we're part of something much larger? Meanwhile, ordinary people are rediscovering wonder. Public observatories report record-breaking attendance. Families gather outside at night, looking through backyard telescopes, searching for a glimpse of the faint light. Teachers are rewriting lesson plans to include the visitor. Scientists are live-streaming data analysis, answering questions in real time. For the first time in decades, Earth feels united by curiosity, not conflict. It's as if this object has held up a mirror to us, not just a literal reflection of sunlight, but a reflection of our hopes, fears, and possibilities, whether it's natural or not, whether it carries life or just rock. It has already accomplished something extraordinary. It has reminded us that our story is bigger than Earth, that the sky above is not an empty ceiling, but a doorway, and we are just beginning to open it. Humanity stands at the threshold of a revolutionary age. The arrival of this colossal interstellar object, combined with the earlier visits of ʻOumuamua, 2I Borisov, and 3IATLAS, signals something profound. Interstellar encounters are far more common than previously imagined. No longer are these events rare curiosities to be observed once in a lifetime. They are part of a dynamic, ongoing process that shapes the galaxy itself. Astronomers are now calling this emerging field the study of galactic travelers. It's a branch of science that transcends traditional comet or asteroid observation, focusing instead on objects that carry with them the history, chemistry, and potentially even the seeds of life from other star systems. Each new visitor provides a real-time laboratory for studying planetary formation, chemical diversity, and interstellar dynamics. The global coordination of telescopes, satellites, and AI-powered observatories marks a turning point in human capability. We are no longer passive watchers of the sky. We are active participants, tracking, analyzing, and preparing for the next visitor. Future missions, robotic flybys, sample returns, even potential interception missions could transform interstellar science from speculation into hands-on exploration. Beyond science, this era challenges humanity to rethink our place in the cosmos. Our solar system is no longer an isolated bubble. It is a crossroad of the galaxy, where matter, life's ingredients, and perhaps messages from other civilizations drift silently across the void. Every interstellar visitor is a reminder that we are part of a larger story, a universe alive with motion, complexity, and interconnectedness. The coming decades may see regular monitoring of interstellar objects, new technologies designed to chase them, and discoveries that could redefine chemistry, biology, and our understanding of life itself. Each encounter strengthens the bridge between imagination and reality, showing that the galaxy is not distant and unknowable, but close enough to touch with curiosity and science. This is not just an astronomical event, it is an invitation to look up, to wonder, to participate in a shared human adventure that spans stars and light years. And as we study these galactic travelers, we may finally begin to answer questions that have haunted humanity for millennia. Are we alone? How common is life? And what messages are drifting through the void, waiting to be discovered? If you're as fascinated as we are, don't miss a single update on these cosmic travelers. Like, subscribe, and hit the notification bell to join us on this journey, because the galaxy is sending its stories, and you'll want to witness every chapter as it unfolds.